Hello again, ladies and gentlemen. This is 6.8, volume of pyramids and cones, and I'll be your teacher this evening, Mr. Smith. For this lesson, I actually forgot to delete this part. There are some videos linked in the notes that I have given you. Feel free to use those. I'm not going to blame you if you don't view them. It's entirely up to you, entirely optional. With that said, let's just jump into this. It's pretty straightforward once you have the formulas. So, to calculate the area or the volume of a pyramid, if it has a square or rectangular base that meet at a certain point, so just like this, there is in the red shaded region, there is a square or it could be a rectangle. There's only one formula for this, and that is length. So length times width times height, all divided by 3. And if I were to label this formula, the dashed line would be h. This could be the length here. This would be the width here, because it's basically just the area of the base times the height, all divided by 3. And you're going to see something really similar with what's coming up next. So in the cone, this is actually an incomplete diagram because we don't have the height. Say we have a dashed line, it ends here, and a dashed line out here. Well, we know this is our radius, and we're going to be using that. Spoilers. A cone, to find the volume of a cone, it has a circular base where all the sides, or the side, meets at a single point. You guys have seen a cone before, like an ice cream cone, something very similar to that, or a party hat. To calculate the volume, it's pretty straightforward. It's area of a circle, so pi r squared, times the height, all divided by 3. So these are really similar to prisms and area. So it's a lot of overlapping knowledge. Basically, you're just finding the area of the base, multiplying it by the height, and then dividing by 3. So find the area of the base, multiply by height, then divide by 3. Make sure I label that. Perfect. All right, let's go on to some examples so that you can see this in action. So, example 1, we have a rectangular base, so determine the volume of each figure. This is pretty straightforward stuff. Basically, I'm going to label it. My height goes here, length and width. What's nice about a rectangular base is if you label it wrong, it's not the end of the world. It's not going to mess up everything. However, if you mislabel a cone, that could be very, very bad and very, very frustrating. So your volume is going to be length times width times height, all divided by 3. So now we just sub in the numbers. So I'm going to just do another equal sign here. 3 times 2 times 1.5, all divided by 3. And this should be 3 centimeters cubed. Perfect. And that's all there is to calculating the volume of a pyramid. A square base or rectangular base pyramid. Next example is a cone. Cones can get a little bit trickier, but this one's pretty straightforward because we're given R, we're given H. In this case, it does matter where you place things because you have pi times r squared, and that squared part is what will mess things up. So pi r squared times h, all divided by 3. We need to sub in the 4 where r is, because 4 is what's going to get squared, not the 11. If you square the wrong number, you're going to end up with the wrong answer. So your radius, you guys should know what a radius is at this point. You've seen circles for a couple years now, and have seen radiuses for a couple years at this point. At least 1 or 2. And at this point, we plug things in. So it's going to be 4 squared times 11 times pi all over 3. I'm going to sub in the numbers. After I sub them in, I plug them into my calculator, and I get 184.3 centimeters cubed. Centimeters cubed, not centimeters squared. Okay, the next example is where things get a little bit tricky. We're not actually given the height. So if I have this height, actually, let me change the pen color, because this is going to get weird. So I have the height here, h, which isn't given, and I'm not given r. But I am given the diameter. Well, we know diameter is equal to 2 times r, and we know this is 16 equals 2r. To get rid of the 2, we just divide both sides by 2, and we get 8 is equal to r. Okay, perfect. So we got one measurement. Tough part about this is figuring this part out. This is a step that students miss every time. I taught grade 10. I haven't taught this course, like I said to you guys before, but in grade 10, students forget this part. I have to explain it over and over and over and just hope that they get it. Don't mess up this part. There's a triangle here, and I'm going to draw it. Let me use another color just to illustrate this a little bit better. Let's go with green. There's a triangle here, and I'm going to go on the outside of my height. Looks something like this, and it's a right angle triangle. We know this is 15 because it's given to us right here, and we know r is 8, so that we know that's going to be 8 centimeters there. We have a right angle triangle, and we're missing a side, so we're going to be using Pythagorean Theorem. So our next step to figure out h, it's going to be h squared plus 8 squared is equal to 15 squared. Right? Because this is a squared plus b squared equals c squared, which is our Pythagorean theorem. Now that I've subbed things in, I can actually start doing some calculations. If I'm doing my calculations correctly. Actually, before I really dive into that, I want to illustrate this as a triangle here. 15, 8, and then h. And this is why I'm using this, because it is a triangle, and I need to figure out the unknown side. So I use Pythagorean theorem to do that. So I'm going to end up with h squared equals 15 squared minus 8 squared. So that's going to be h squared equals 161. Take the square root of both sides. I'm left with h equals about 12.7 centimeters. It's not centimeters cubed or squared because it's just a length. So we got h. Perfect. We have r, we have h. We can now solve for our volume. I'm going to switch back over to blue because I like using blue. It's my favorite color. I'm going to split up this note a little bit. There we go. Perfect. Our volume formula is just our area of a circle, pi times r squared, and then times h, which is our height. And we know all of these now because our h is given over here. So we can sub this in. Pi times 8 squared times 12.7, all divided by 3. Plug that all into your calculator. You should get 851.2 centimeters cubed, right? Because it's volume, so it's cubed. All right, that is the end of this lesson. Make sure you do the practice, ask any questions if you have any, and then do the quiz afterwards. You guys have a whole week, so you should be able to get it done. Best of luck, and I'll hopefully hear from you guys soon.